It's a pleasure to be here and to see so many of you here. Thank you for coming. Thank you for supporting us. And it's very good to be here in the interest of cybersecurity. I've been with Fortinet for 14 years now, so I'm very interested in cybersecurity. And I want to talk about the journey, the evolution that we've seen over the past years, where we're going in the future. Myself, I consult CXO around the world. I do thought leadership, looking at security vision and roadmap. I lead our FortiGuard security operation team at Fortinet. And I'm also working in industry, trying to solve real-world problems with collaboration, threat alliances, and partnerships as well. And so I want to explain some of that story to you so you can get a better understanding and talk about emerging trends and our FortiGuard artificial intelligence, which is a big word everybody is talking about today. Starting at Fortinet, for 18 years, Fortinet was founded in 2000. For 18 years, we have been building FortiGuard. This is not new. As Peter just said, this is a marathon, not a sprint. This is the marathon. It's been 18 years in production. We have grown from when I started 14 years ago, from about 20 people working in our security operations to over 215 threat experts now, worldwide, in various research centers. That's a big force when it comes to threat expertise. We started with antivirus and web filtering. And now, as you can see from the variety of services that we have across our security fabric, we're covering end-to-end for the attack surface, which is very important, right? With digital transformation today, there's a lot of holes that open up with complexity in the attack surface, with more integration. And so we have to cover that in terms of automation, expertise, and services. So we've been building this cohesive fabric, integrated intelligence with FortiGuard now, for 18 years. This is a very important aspect with strategy, as I'll talk about coming up. We've crossed a lot of milestones. Just last month, we issued a release from our CTO, Michael Z, leading an industry for a security vendor in terms of patents. We have over 500 patents now, in fact, 536 security patents issued, over 200 pending. A lot of them are FortiGuard related for advanced threat detection. And I'll discuss this a little bit further with our artificial intelligence and so forth. Because we have coverage end-to-end on the attack surface, we have the capability, a unique capability, to be able to see in real time, globally, but also here in South Korea, attack activity that's happening, right? End-to-end. And this is just on average over the last quarter that we see. Very big numbers. We're seeing over 8 million hacking attempts. These are our intrusion sensors that are going off worldwide in just 1 minute. 8 million. This number is nearly doubled from the quarter before. And I'm going to explain why this is happening. It's a lot of automation happening on the black hat attacker side, right? Just as security vendors and the good guys were creating artificial intelligence and automated solutions, the bad guys are very clever too, and we're seeing a lot of innovation on their end. We're also seeing a lot of botnet attack activity happening here, about 64,000 in a minute. So these are beacons going out to try to exfiltrate data, intellectual property, and so forth from systems. And we're continuing to discover new vulnerabilities in systems. This is a big problem out there. The amount of vulnerabilities that are being discovered in products, in systems, in software has doubled over the last year. It's up to about 14,000 new security weaknesses or vulnerabilities in just 1 year that are now being mapped. It's a very concerning number. We've built up a worldwide infrastructure, so we serve our customers. We have over 400,000 customers that we have to serve. Our primary data center is in Vancouver, where I'm from. It's our primary R&D center. We have over 850 people, actually, in Vancouver. As we create coverage for all of these different services through automation and through our human experts, we're pushing that out across the world to different co-locations, across EMEA, Asia Pacific, America, Latin America, servicing those updates. So it's a real-time update. We're actually releasing antivirus definitions every hour, web filtering every 5 minutes. We have to do that because we have to stay on top of the agile attack methods that we're seeing from the black hat attackers as well. As I said, obviously our customers and our business solutions are priority. They're number one. But I wanted to do more, right? So we're taking our threat intelligence and we're actually working in industry to try to solve problems, right? To try to make it more expensive for cyber criminals to operate. As a C-level consultant, how do you make it more expensive for an attacker to get into your systems? You build up a more robust, integrated fabric and security solution. From an industry perspective, we're doing many things. One is the Cyber Threat Alliance, I'll talk about later. We're a founding member of the Cyber Threat Alliance. So we've teamed up with other security vendors to share intelligence and expose attack campaigns that are happening for attackers. We're also working with various ISACs around the world, including financial services, different verticals. We're working with enterprise. So we're contributing to Verizon, the data breach investigation report. This is FortiGuard Intelligence. We just recently announced a partnership with IBM, X-Force, globally. So we're teaming up to work on research projects. We've been a partner with Microsoft since 2006. They give us trusted information before Patch Tuesday, so we can roll that into FortiGuard IPS updates in advance by the time they hit. On the same side, we're also trying to solve other problems in terms of law enforcement. So we're actually teamed up with Interpol. I sit on an expert working group with Interpol. I meet once a year in Singapore at the IGCI cybercrime complex. And we're actually working on exposing who these attackers are so that law enforcement can go in and prosecute. It's a very important aspect because it makes it more expensive again for these cyber criminals to operate and places less burden onto the customer. We've also signed agreements with NATO, the NCI agency, so protecting allied countries, typically against cyber warfare threat. On the National Computer Emergency Response area, we're trying to disrupt cybercrime, find infrastructure, malicious hosting servers, and take them offline. We've had a lot of success with this, actually starting here in Korea with KISA. So we announced an MOU several years ago now with KISA. We've had technical workshops with them, so FortiGuard researchers working with KISA researchers and analysts to work on case studies so we can learn about more attack activity happening here in Korea and provide protections into the Fortinet ecosystem. We're also working with other CERT worldwide in Taiwan and CCST, the US CERT, DHS, and so forth too. The idea here is that because we have intelligence, we can share that so that national CERT can also act on that. And so this is what we're doing in industry partnership. Okay, so looking at activity that's happening in Asia Pacific and in Korea, there's a lot. We break it down by virus activity, intrusion. Application obviously is the most traffic that we see. Everybody likes their social media applications, of course, and business applications. But these are in the millions. And just in Korea, as you can see, it's about 2 billion. This is for the last quarter in 2018. About 2 billion hacking attempts happening in total in Korea. 2 billion, not million. That's a lot of hacking attempts that are happening here. In fact, it accounts for about 4% of all of Asia Pacific. We're still seeing a lot of activity also on endpoints. So this shows end-to-end attack activity that's still happening. On the endpoints as well, quite a bit of attack activity. About 2 million detections on botnets as well. So what this means is that there's still a lot of infected machines that are sitting here in Korea, beaconing out to attackers, right? This is on the botnet side. So this is what we're seeing on the end-to-end coverage. There's a different makeup here also from what I've seen in Korea versus Asia Pacific. Looking at sector coverage in Asia Pacific, manufacturing generally is hit a lot more by viruses, typically in China. That's one of the largest concentrated areas. Here in Korea, the viruses are mostly being hit in the technology sector. That's a hot area that we see. And MSP as well, for managed security service providers. What you'll see here on the side is a breakdown of that. So this is for Korea. As you can see, in terms of viruses, technology is being hit the hardest. The dark blue graphs that you see are for intrusion prevention. So these are the hacking attempts that are happening. And again, mostly concentrated between MSSP and technology. Mostly on the MSSP side for the intrusion attempts. This is very interesting as well. You know, when I look at attack activity for Asia Pacific, it's a blend between different targets. So I talked about that very large, 14,000 vulnerabilities that are being discovered every year. In Asia Pacific, a lot of those are being targeted towards things like Apache, IIS, web services, right? Trying to hack into web services and then move laterally inside servers from data centers. There's some IoT activity when we look at Asia Pacific as a whole. But here in Korea, what do you see when you look up here? A majority of these attacks are IoT related. So IoT is very hot here. You can see everything from routers, CCTV, DVRs, being attacked. A lot of these are also weak vulnerabilities, so they're going after unauthenticated remote code execution. These are typically flaws in the web daemons, the web servers that are sitting on these IoT devices. There's a lot of these easy flaws that are discovered, and we're seeing direct capitalization of this from attackers in Korea. So there's a very big, important story here, of course, because this is hot. This is our intelligence that we're seeing. There's a big crisis in terms of patch management, of course, trying to find available patches. But it really places the emphasis on having to have proper IoT strategy in organizations in terms of segmentation, risk assessment and monitoring, in terms of IPS, having proper IPS coverage to plug those holes as well. So in global trends, I'm seeing a very fascinating thing. If we look at the cybercrime ecosystem, that's what drives a lot of this. It's about monetization for cyber criminals. Traditionally, cybercrime has been human-oriented, right? So there's CAAS, crime as a service. So crime services, if you want to take some money and investment and rent a DDoS attack, rent a money laundering network, you can do this through crime services. They're typically available on darknet sites. Likewise, if you want to get attack code and go to a development house, you can do this as well. These are the producers of crime kits, creating those new attack kits that are attacking those newly discovered vulnerabilities, like in the IoT devices, right? Also creating new Trojans, botnets, and things like this. This has been going on for years, a typical cybercrime ecosystem. And they've injected affiliate business models, so middlemen, right, that get paid commission to infect systems. This is a $1 trillion plus industry globally. Typical cybercrime organizations that we follow are making in excess of for business email compromise scams, some of them can make over $50 million US in just 3 months from our research that we're finding. But it's very human-oriented. And humans are slow, right? An attacker needs to go through multiple stages in order to get to the target, to get to data, intellectual property, credit card information, identity information, and so forth. The trend that I'm seeing is an accelerated attack chain. This is after the Lockheed Martin cyber kill chain. The concept here is that for any attack, there's no magic bullet. You have to go through multiple phases. The first phase is planning. You got to know the target. Who is your target? What are the weak spots? How do you break in? Once you know the target and you've done the reconnaissance, then you break into the target. This is when you're penetrating the system, you're exploiting vulnerabilities. Once you get into the system, typically you have to hop between other systems in that network. In the world of IoT, we're talking about moving from DVR device to a printer to a server or a network-attached storage somewhere, right? This is laterally moving and expanding. After that, obviously, you have to gather information, find the intellectual property, the payload that you want to extract, and then somehow have a vehicle to take that out of this system and take it back to monetize. So this is the concept of the attack chain. This has always been human-oriented, but what I'm seeing now is that there's a lot of automation being put on the attacker side to accelerate this. So this used to take a month to launch a full-fledged attack from humans, right? So this is the time to breach, how long it takes from the start of an attack to success of attack. We used to talk about this in months. Now it's gone down to weeks. It's gone down to days. In the future, we're talking about latency, similar to the stock exchange here. You know, attacks that are going to be happening almost at wire speed. And we're starting to see research. We're finding research on this, right? One good example through automation is Autosploit. This is a framework that's been launched globally that allows, it connects two toolkits together, Shodan and Metasploit. Shodan is a toolkit that does blueprinting. It's a giant blueprint of vulnerable devices all around the world. So that takes care of that first part of the attack chain. It has a knowledge base of weak spots and where they are around the world. This framework, Autosploit, has connected that with the Metasploit framework. So what it's actually doing is it's automating, right? It plugs into Shodan, it says, give me a list of all these vulnerable targets, and then it connects that to Metasploit, which is a commercially known penetration testing tool, to actually go and attack this. And what this means is through this framework, you set up a Kali Linux server, so it's just a virtual machine you can set up, and it's about 3 commands. 3 commands, and you can be hacking hundreds of thousands of servers around the world. This is a problem, right? Because it's starting to empower cyber criminals to be able to accelerate that attack chain. So this is a good example of automation that's happening out there. Okay, so a year ago, I work on our threat predictions every year, and this is a way to look at our research and see what's coming ahead of the curve, what's in store for next year. This was actually a year ago, almost a year ago today, that we released this. And the prediction last year was that we're going to start to see the rise of self-learning networks, self-organized systems. These are swarm networks, right? We've actually seen this has come true. We've seen indications of this happening this year with our research. Before I talk about how that's happening, I want to just explain the concept of swarm quickly. So not a lot of people talk about swarm. It's been around for a very long time. It exists in nature, right? So if we take the simple example of ants, right? So you have ants, flocks of birds, bees. They all utilize swarm intelligence. And the idea is that you have multiple agents that can communicate with one another to solve a bigger task. Ants use this to form bridges so that other ants can cross, right? Birds use this with flocking mechanisms. Ants also use it to find food, the shortest path to the nest. If there was just one ant in this diagram, it would be wandering aimlessly around a maze, and it wouldn't be too efficient trying to find food, right? Likewise, if you had 10 ants in this maze and they didn't communicate with each other, they would be bumping into each other, walking around, it wouldn't be efficient. But because ants communicate, they actually lay chemical trails, pheromones. One ant can tell another one, hey, I found a shorter path to the nest, right, to the food, and by doing so, they start to form an optimal route. So this is in nature. It's been adopted in computer science. It's been used for routing algorithms. It's been used to solve the traveling salesman problem. It's been used for emergency response vehicles, how they can quickly deploy, right, and find the shortest path to the nest or to the target. And this is just one example of swarm in nature that's been applied to computer science. It's also being applied to robotics, right? So this comes from Harvard University. They've created a self-organized system research group. What they created was a swarm of robots, right? So this is called kilobots. It's 1,024 robots. They're about less than the size of my hand here, one robot. 1,024 of them. They communicate using infrared technology. And the idea here is that instead of a computer programmer having to program all these instructions of what to do, they just tell it what to do. They say, I want you to form a wrench or a star. They give it a shape, and that's it. And the robots are smart enough to start talking to each other and self-assembling. If you were to take your hand and take a whole bunch out, they would come right back in and assemble into that swarm. So they're using swarm intelligence in robotics as well. Now, we're starting to see this technology in cybersecurity. This is the very interesting thing. If you look at botnets, right? So in the world of cybersecurity, we talk about botnets, of course. Botnet is an infected source of machines that communicate with the attacker. The attacker tells the network what to do, right? They say, go launch a DDoS attack, go launch a phishing campaign, go give me that intellectual property. But it's all controlled by the human, right? Well, humans are slow, like I said again. And so what we're starting to see with swarms is the attacker being removed largely from the equation, right? And infected computers that can start communicating with each other to send and receive commands instead of the attacker doing it. And this is how we're starting to see that attack chain being accelerated. It's taking the human more out of the loop so that the time to breach can be quicker, so that it's harder to detect their footprint as well. And this is what we're seeing with them. A good example this year was the hide-and-seek botnet. So this is the world's second decentralized IoT botnet. So what that means is that it's peer-to-peer. It's based on IoT nodes. So it supports IP security cameras, routers, DVRs, even x86, so PCs as well. And the idea here is that we've actually researched this code. The infected IoT devices can actually communicate with each other and send and receive commands. So one device can receive a list of other devices with a command. It can ask another device, hey, send me all of your files, right? Send me all the different IP addresses or servers that you know about, and they can start doing this. So this is phase one of swarm intelligence that we're starting to see with attack code. This is a simple theoretical example. If you have a swarm of infected IoT devices here and an uninfected security camera sitting in the middle, one device can discover this vulnerable device to attack, notify the rest of the swarm via its communication that it's found this device, and then each device can try to penetrate this vulnerable device. So instead of just one node having a chance at attacking the device, you have all these different vantage points that can try to attack the device, right? So it increases efficiency, it makes it faster, and because the human's not in there, it means that these devices are actually working more at wire speed. So this is an actual research case that we've found. Intent-based solutions. So we're moving into an intent-based world. You know, there's so many security events happening, as you saw earlier. I was saying 8 million hacking attempts in just 1 minute we're seeing. That's a lot. How do you start to move strategically to protect against that? From a human, even from a CSO perspective, it's very tough, right? It's very difficult. How do you prioritize this? You have to start relying on intelligent solutions, right? Intent-based solutions. It's interesting here because we saw a case of AI being applied to a gaming problem, right? So this was an intent-based solution. It's very simple. This was from a German research group, March this year in 2018. A lot of you probably know this game. It's Atari, old school, Qbert. Very simple, right? All you do is just jump up and down the levels, play the game, get as many points as possible. You advance levels, you get more points. Typical video game, and it's from the 1980s, very old. But the AI system that they created wasn't saying, do this, do that, go to the next level, get as many points as possible. When they developed this AI system, they said, I don't care how you do it, but your goal is just to get as many points as possible. And they expected the AI system to start playing the game, jumping down the levels, going through levels and getting more points. There's a nice animation of this that you can find out there publicly, but what happens basically is the AI system starts playing, it never leaves the level, it starts hopping around, and all of these start flashing all these different colors. And all of a sudden the points just start skyrocketing up. And they, after the AI system had played this, they interviewed the original developer, designer of the game. He said he had never seen this behavior before. What happened was the AI system actually found a weakness in the game, a vulnerability, and it hacked it. It exploited it. So this is an example of how AI can also be used for hacking, and how this was a proof of concept. But in the future, where we're heading is we're going to start to see AI hacking, AI fuzzing, AI research that's being put on the black hat side, which is going to even accelerate the attacks against these weaknesses more. So that's what's coming down the pipe. So how do we start to defend against this, right? I mean, that's very scary what I'm talking about, and we're starting to see actual activity happening there. So we need several tools, right? We need people, we need process, but we need technology too. We need automation, and we need artificial intelligence. Now, artificial intelligence, a lot of people talk about AI. A lot of these solutions are new, popping up. For us, we've actually developed our FortiGuard AI solution for 6 years. We just launched it this year, but it's been in development for 6 years. Why? Because AI takes time. You need time. Machines learn just like humans do. They learn faster, but they learn like humans do, so you need time. You need data. We have a lot of data at FortiGuard, and you need to train these systems with a lot of data, right? And you need supervision. And this is what we've done. We've actually repurposed our human experts at FortiGuard to be able to train our AI systems. And the AI systems have taken over the day-to-day jobs that our human FortiGuard experts would do, and our experts have now moved into training positions. It becomes much more scalable this way. So very simply, what we do with FortiGuard AI is we train it. We have a blank mind, right? And we start feeding it virus samples, attack code, and we start training it, saying, with our human experts, saying, this is attack code, this is not attack code, right? Very simple. This is malicious, this is clean. And we keep doing this with more and more virus samples in there. As the system learns, it starts learning features, different characteristics, we call them features, about these viruses, right? It's a very big database. There's over 9 billion features that the system has now mined going through training. So after we go through all this training and we tag it and test it, train it, we go through testing. So this is where our training experts step away and say, okay, and start feeding it random samples, right? And asking the system what it thinks. Do you think this is malicious attack code, or do you think it's clean? And the system starts rating it, right? Obviously, at the start of this process, when you don't have a lot of data, the system's not that accurate, right? It's going to make mistakes, and it does. So in the first year and a half of us training this system, it wasn't as accurate as our human experts were. But we found after a year and a half of testing, training, and repeating this, the system actually started to become more accurate than our human analysts did. And this is why we've moved to this training model. It's very interesting and very scalable, like I said, too. So this is the end result, right? What we've done is created an AI system. It's through an artificial neural network where we can feed attack code in, and the system, at a very high degree of confidence now, can say, yes, this is attack code or this is not attack code. And so after 6 years of development now, we've actually launched FortiGuard AI. This is through our antivirus solution. We've put this into our sandbox technology as an example, anything that has FortiGuard antivirus, you're going to be getting this benefit now. So it's very powerful, right? Through our sandboxing, through our FortiClient on the endpoint, FortiGate, obviously, as well on the gateway. The idea here is that as 6 years have progressed, that degree of accuracy is getting better and better and better. And it can make inline decisions to actually block attack code, which is very important. Because if it's just giving security logs and then a network administrator comes in later and tries to correct or create a new policy, it's often too late. And this is why we need AI to start tackling these solutions. Okay, so moving on to industry, Cyber Threat Alliance. I have been with the Cyber Threat Alliance since day one, which was May of 2014. Fortinet is a founding member of the Cyber Threat Alliance. In fact, originally, it was just 4 founding members. It was Fortinet, Symantec, McAfee, and Palo Alto. I developed the original bylaws for the Cyber Threat Alliance. We've gone through a lot of changes, so I just want to brief you quickly, because you're probably hearing more about the Cyber Threat Alliance in industry. What started as just 4 founding members, we've added 2 more charter members last year, Cisco and Checkpoint joining as well. We continue to add more affiliate and contributing members, right? So affiliate members of the Cyber Threat Alliance, we've created a whole ecosystem. We've created workshops, special interest groups, so committees, looking at data quality, algorithms for threat intelligence. We've created a platform centrally that all the logos you see up here are actually plugged into and actively contributing and sharing. And there's a lot of competitors you see up here, right? So it's a very powerful statement, because we have competitors, but experts in this space joining forces to level the playing field on intelligence. Of course, we remain competitive on the technology. For us, it's our security fabric strength and solution, because we can take intelligence and cover it end to end in the security fabric. But we wanted to level the playing field on the attackers so we can share in real time threat intelligence information to make it more expensive for the cyber criminals to operate. Recently, we've added NTT Security, NEC, IEC2 here, Saint Security and SK InfoSec also from Korea as well. Dragos is also a new member that we just added in the last month. So it's been a very good, successful project. And again, each member here is rolling up their sleeves, putting engineering resources in, and actually contributing to the alliance. The board of directors is the CEOs of the vendors that you see here, including Ken Z, our CEO at Fortinet. I actually get together with them once a quarter for board meetings. And myself, I sit on the steering committee, and we're actually trying to obviously steer the direction of the alliance into a unique place in the industry. Michael Daniel is a CEO and president, former special assistant to Barack Obama as a cyber advisor, and working very closely with him. So throughout this Cyber Threat Alliance platform, we've plugged in all of these members globally, worldwide, so that intelligence can be shared in real time. And as I said, each vendor is going to have their own solution to this. In Fortinet's case, we're getting all this intelligence and we're putting it into our fabric, right? So we're getting indicators of compromise, we're adding protection into web filtering, intrusion prevention, into antivirus, into our advanced malware protection system for Sandbox as well. Some other good examples apart from the automation. So we're doing that automation piece when it comes to sharing threat intelligence, which is very important, by the way, because like I said, we need to be able to share real-time information, real-time. It's very important to be able to share real-time because of everything I talked about, that attack code, that accelerating attack chain. Everything's happening at rapid pace right now, and it's always an arms race. So we're trying to get ahead of the bad guys to be able to actually share that intelligence and deploy protection before they can actually get into the systems and get out. That's one of the main goals. So elevate overall security, disrupt cybercrime and the malicious actors is another big statement on there as well. The other thing we're trying to do is to have a voice, so work collectively in industry and share trusted relationships. This is a good example. VPN filter, you've probably heard of. This was released, there's actually 2 releases on this, but the first one was released a couple months ago. This was a SCADA, right? So OT, operational technology attack. That was, it had a specific sniffing protocol that was being put onto routers that was sniffing for SCADA, so critical infrastructure traffic. So very serious threat. This was actually led by Cisco Talos. But as an example, Fortinet, we got a phone call in advance, days in advance, before any blog, before any release was put out to public. So these are trusted relationships that we're building so that we could get the intelligence, create our own blog in response on it, work with Talos, and also deploy security updates to FortiGuard before any security blogs went out. There's another one that just was released today, you probably saw, from Symantec, Gallmaker. Just today it was released this morning. We also worked on this over the last 48 hours at Fortinet through another trusted relationship with Symantec we're doing. So these are good examples of humans working together. We have the automation piece there, but we also have the humans working together to solve these problems. And that's a very powerful thing. When you start to pool engineering resources and bright minds together on phone calls and in a room too. CTA traditionally has worked on other papers. 3 years ago, we worked on CryptoWall version 3. This was a success, very good. That was the largest, one of the largest ransomware attacks at the time, one of the most successful, CryptoWall version 3. We released a 75-page white paper on it, exposing Bitcoin wallet addresses, all these different tactics that the cybercrime operators were making, and they made about $330 million on that specific campaign. But the day that we released the attack report, the next day, they tried to change. They knew that that attack wasn't going to work anymore. They came out with CryptoWall version 4. Version 4 wasn't that much of a success. So it was a good success for us. It shows how by exposing cyber criminals more, is making it tougher. We're forcing them to go back to the drawing board, to the engineering board on their end. Just this month, we also released a new one on the cryptocurrency mining threat. This is a big global trend that we're seeing. In fact, from our Fortinet, we released our, every quarter we release our threat landscape report, so I welcome you to go and look for it. You'll see in our threat landscape report that one of the most prevalent threats, in fact, 23% of organizations now that we're seeing are getting hit with crypto mining threats, right? So these are threats that are obviously infecting the systems, trying to capitalize on processing power, right, in order to mine cryptocurrency. And obviously, in production and business environments, this can lead to DOS, denial of service, which can disrupt critical business revenue streams as well. So a very big issue out there. Some people might think, well, if someone just borrows a little bit of my processing power, what's the big deal? But it actually has a lot of significant consequences. Not to mention, it's an infection that's talking to an attack server out there too. Okay, so that's everything I have here in summary. As some takeaways again for this, like I said, we're seeing an explosion, particularly here in Korea, on IoT devices. That's the number one threat, as I said. We're seeing so much attack activity. There's a big problem out there, as I said, in terms of patching. So from a strategic perspective, you have to look at things like risk and management assessments. Segmentation is very key. Protecting your digital assets as well, having agile and macro segmentation in place, advanced malware protection, so sandbox, critically important as well, because we're seeing a huge growth in unique malware, new malware families coming out, and that means that they usually try to evade typical antivirus signature-based systems. So you need deep inspection, and you need fast inspection, right? So that's another good example of what we've done with FortiSandbox, connecting that to our fabric. Just like the swarm I was talking about on the Black Hat side, we've created our own swarm through the fabric, where our sandbox is able to talk to the gateway, and our FortiGate can start blocking those attacks. This is part of the security fabric story and how we're responding to this threat. Came here all the way from Canada. It's been great to speak with you. Rest assured, we have worldwide experts working 24 hours a day, 7 days a week, 365 days a year to be able to research these threats, work in industry, but continue to launch new innovative services and solutions with our Fortinet engineering team that we can bring to you and the rest of the world. Okay? Thank you very much for your time.